It wouldn't be sci-fi summer without taking a trip to southern Nevada to Valley of Fires State Park. Valley of Fires is located about an hour east of the big city of Las Vegas, Nevada. And it was the filming area, the signature area, the landscape used for the planet Viridian 3 in Star Trek Generations, the movie.
Dr. Bridge.
Warp here, sir.
Set a course for the Viridian system, maximum warp.
This was the place of Captain Kirk's ultimate demise, his burial place here in Viridian 3 / Valley of Fire State Park.
Oh my.
This is the Aztec Formation. It's a Triassic to Jurassic aged sandstone that was during the age of the dinosaurs. And this rock was formed from a giant dune sea. So dunes like you would find in Saudi Arabia or in the Sahara Desert today. And the wind was blowing these giant dunes of sand across this valley, and these rocks were eventually preserved as this very thick, clean sandstone. You can see lots of wavy bedded things in here, and those are actually the different surfaces of the dunes as they migrated back and forth across this valley.
Nice try.
But the underlying geologic event that sort of formed this place was called the Keystone Thrust. And the Keystone Thrust is actually a part of a much larger complex of faults, go all the way up into Canada. And it's a type of fault called a thrust fault. And a thrust fault occurs not when one side moves down relative to the other, but when one side sort of gets pushed up and over the other side. And so what happens is this sort of loads this area down, right? And so you get this sort of tilting and erosion. And in this case, we get this limestone that's been shoved up and over. It kind of tilts and deforms the park. And now it's eroding. So we now can see these jagged sort of rocks sticking up, much like the ones that you see in the film where Dr. Soren built his, his weird like metal missile firing platform from. And a lot of those harder rocks on top, and then these softer red rocks down below. The rocks that make up Valley of Fires Park, including the Aztec sandstone, are early Jurassic in age. So they would have been about 180 or so million years old. And it was about 65 million years that this limestone was thrust up and over. Much later in time. So a very complex history of a basin filling with rocks, these sand dunes that are sort of coming off at the end of the time of the Pangean supercontinent, because the Jurassic was starting to come out of it, into the Cretaceous seaway and some of the other things that were about to occur. And then this, what we call the Laramide orogeny, ultimately that kicked off for 65 million years. And that's what formed the Rocky Mountains. So this giant push with this slab of what was essentially a subducting Pacific plate that sort of floated underneath, we think, and was kind of shoving the North American continent inward. And that's why the Rocky Mountains form so far east. Normally, if you look at all the other continents in the world, like South America and the Andes, they form very close to the actual boundary of the plate. But the plate boundary here is actually shifted, and the mountains in 65 million years ago were flat out in Colorado. Why is that? There's still a lot of conjecture, but we think it's because of the subducting plate, and it rode underneath, started to melt, and it was basically pulling the stresses way further inland, and in fact was actually stretching behind it. And that's why we even later get the basin and range, which formed a lot of the mountains in the area of Las Vegas and central Nevada, even younger. So very complex, cool history to this part of the world with all the different mountain building episodes layered on top of each other. It's very complex, but pretty awesome.
Yes!